Hey y'all, I am back in the data set for our class for a little mini study where we talked about social loafing. And I have a histogram for age here and some other graphs. And I'm just going to talk about the ways that we can use graphs to understand continuous variables in this video. So this histogram, we can see that Jamovi has created bins, which is these bars are considered bins, and Jamovi automatically chooses the size of the bin, meaning that there's a range of values that fall into each bin, and we can't actually control that. Which is why I don't usually use Jamovi graphs for reports. I just like to visualize with them. But here, I just want to go over briefly what this tells us. So this says density on the side here. In terms of a histogram, what we're really talking about is frequency. So a bar that is the highest indicates the highest frequency. We can see here that this pattern really shows us that the majority of students in this data set are younger. And then we have a couple that are older, right? So this is a positively skewed or a right skewed distribution. And the skewness tells us that we're going to also report the median. We want to report that median that I talked about in the previous video. So this is right skewed or positively skewed. So in this case, our median value was about 20 and a half. So our median is probably somewhere around here. This would be our median. And so what that means is that about 50% of responses fall below that number, and then 50% fall above that number. And you can see that the lower 50% has a lot less variability. It's a lot less spread out. Whereas this upper 50%, there's a much bigger range here. It covers a much bigger number of ages. So our mean, by contrast, was almost 22 years. So our mean is probably around here somewhere. It's getting pulled up by these numbers here. So the mean is getting pulled, and that's why we call it right skewed. The mean is skewing to the right. If it were perfectly symmetrical, so if we were looking at a symmetrical distribution, we would see that our mean and our median were right on top of each other or right next to each other. And then we would have these sloping values where people were gradually, there are fewer people that fit gradually as we get closer to the ends of this distribution. But that's not the case. We have this right skewed distribution. So the median, or rather the histogram, does show us the shape of the distribution, and it's quite helpful to look at this and we can see a lot about age in our data set. There are other ways to visualize continuous variables though. So I'm going to show you a couple of other options. Um, so you can also create a density plot. Now this density plot, if you look here, you can see that the shape is similar, but this is a much smoother representation. And you want to think of this density. We're talking about the area under the curve, and it's a probability density. So it's this idea of the probability that we would get different values based on what part of the curve we're looking at. So for example, if I were interested in um, people who are 35, wanted to know what the likelihood is that I would randomly select someone who's 35. That's at the end here. It's really unlikely that I would get that person or that age because it's a lower part of this density. So we're talking about kind of an area under the curve, and it's not just a single value. We're talking about for example, from here on. So if I were looking for 34 and older, we'd be talking for an area under the curve. This is another way to just kind of visualize that information. And you can also overlay this density plot on the histogram. It really tells you the same information. It just shows it in a different way. Now, again, you can also visualize it other ways. And the last way I have on here would be a box plot. This is also called a box and whiskers. And a lot of people really like box plots. And so it's something where this might sing to you. You might just feel like the box plot really gets across the information that you want. They're particularly helpful for showing us outliers. So these are outliers. Um, and the outliers are kind of the unusual scores, right? The ones that are they're different enough to be considered unusual. And so Jamovi has a calculation for this where it's based on the interquartile range, or the range from this 50%, the middle 50% of the data. And so it's a nice way to visualize it. So this tells me I have some outliers. I have some people who are older than the majority of the other students. So I'm going to clear this off, and I'm just going to show what this shows us. So this line right here, this is the median, and so this is our middle 50%. So this is the median. This is also called this is the 50th percentile. And so when we talk about percentile, if I say the 50th percentile, I mean that 50% of the responses are below this value. And we know that this median is 20.50 because we saw that before. So if I were to draw this out, I could say that this, let's put this over here. This right here is 50% of responses, and then 50% would be here. And you'll see that that looks very similar to what we did with our other graph. It's just showing it in a different way. This right here is Q3. This is our third quartile, or our 75th percentile. So 75% of responses fall here or below this number. And we can actually calculate that in Jamovi. I didn't do that, but you could have it tell you what the Q3 value is. And then that would tell you, again, the 75% that fall from here to the bottom. We also have, this is our Q1, sorry. This is Q2. The median is Q2, which is also our 25th percentile. So this, again, breaks out the information a little bit differently, and it allows us to really see the shape of the distribution and identify what type of data we're working with. So we can see very clearly that we have a skewed distribution. So this was, again, an overview of graphs appropriate for continuous variables. I have videos on the other types of variables available as well. And let me know if you have any questions. Clear all this.